Hello everyone, my name is Filip Stanis and I'm here to talk about what makes a good checkout experience. Now I'm sure everyone here is already aware of how big e-commerce is and the potential it has. But this number here illustrates it quite well. This is the total sales of e-commerce alone in the US in 2017. That's almost $500 billion US. And while this is a US only metric, we're seeing a similar trend worldwide. So you could say that e-commerce is kind of a big deal. But despite the fact that sales are growing year on year, there's one metric relevant to e-commerce that unfortunately remains constant: the conversion rate. More people are buying things, and more people are buying things using their phones. However, it turns out that the people finishing their checkout compared to the people who are actually visiting website, percent-wise, remain pretty much the same over the years. In fact, we've even seen a small decrease in some cases. And we wanted to find out why this is. Now, what you see here is not a real app or a website, it's just a mock that we built. But I'm sure that most of you here are quite familiar with this experience. And indeed, it turns out that 28% of people will, on average, abandon a shopping cart just because the checkout experience is too long or too complicated. There are simply too many text fields and too many steps to complete. And I must emphasize, this is not a case of bad UX. If you want to ship something to the user, you'll have to ask them for a shipping address, and this requires quite a few text fields on its own. At Google, we looked into a way to make this experience better, and here's what we came up with. Our aim here is to let a user complete their checkout in just a few clicks. And what you can see here is Airbnb doing just that. By using the Google Pay API, Airbnb allows you to book a room or a house using just a few clicks. As you can see, when you press the confirm button, a Google Pay chooser will come up asking you to select the card that you want to use. These are the cards you already have stored in your Google account. So in just a few clicks, you've already completed the booking and everything is done. You also notice that at no point the keyword is shown, so there is no need to enter any additional information to complete this transaction. And you can have the same flow in your own checkout experience as well, right now. This is all public and available to everyone. Now, to give you some context of how this came to be, our own users are using our own internal platform on many of our products. For example, the Play Store and YouTube. Now, Google Pay is just an extension of that. It lets you, the merchant, request the user's payment information from their Google account. This is done in a way which is safe, easy, securely transferred, and is also transparent to the user, as it will be completely clear to them what's happening behind the scenes. The hundreds of millions of users who have a payment card stored with their Google account will now be able to make a purchase on any website that uses the Google Pay API through this flow. We already support all the major platforms and browsers, but that's not all. If you can complete your purchase in just a few clicks, then you can also complete your purchase in just a few voice commands as well, on something like the Google Home device or Google Assistant. So we hope that in the future, a checkout experience will no longer be something that's strictly tied to a device that has a screen and a keyboard. Finally, the most important thing of every payment product is how well it integrates with the rest of the payment stack. That's why we're working with many of the major payment processors and gateways worldwide, as well as many of the local ones, to ensure that they are well integrated with Google Pay. You can see some of them on this slide, and if you see any familiar logo of a processor or gateway you already use, then you can just use Google Pay out of the box right now. If you don't, no worries, this list is not exhaustive and we're working with many others as I speak. Now, before I go on to the technical details of how Google Pay is implemented, I just want to remind everyone that everything I'm going to say is well documented in our online documentation, so this is just an overview. I also welcome you to come by our Google Pay stand afterwards, where you can actually try our live demo and also ask any questions you may have. Now, the actual implementation is quite simple. There are only 4 steps you need to do. You load the Google Pay JavaScript library on your website. You call isReadyToPay to ensure that Google Pay is supported on the platform that you're calling it from. If it's supported, you use createButton to create a Google Pay branded button. Once the button is clicked, you call loadPaymentData, which is where all the magic happens and the chooser appears for the user. I'll go through each of these steps separately now. So including the library is quite easy. It's hosted on our CDN, so all you need to do is include a script tag on your website. We always recommend to reload this script asynchronously so it wouldn't block your website, which is why you also want to have an onload function, which is called when the actual library is loaded. Inside of this function, you'll create a Google Pay client. And the only parameter you need at this point is the environment. This parameter is quite simple. You use the test environment when you're developing and testing, and once you're ready to ship, you switch to the production environment. The main difference here is, in the test environment, transactions will not actually go through. So everything else, UX-wise, is pretty much the same. Once we have the client, we should call isReadyToPay. But for that, we'll need to provide a few additional arguments to tell Google Pay what kind of payment we can accept. Now you'll see that most of these slides are actually about these arguments, and there's very little actual code. In this case, we're telling Google Pay who is our payment processor or gateway. This can be Stripe, Braintree, Adyen, or any of the ones that you saw on the slide before. In this case, I'm just setting it to example. Our payment processor or gateway will also usually provide us with a few arguments, such as the API key, user ID, or something similar. In this case, it's called Gateway Merchant ID, but this is very dependent on your processor, so it's best to refer to their own documentation when it comes to this. The next thing we need to do is tell Google Pay what kind of payment method we can accept. Here we are saying that we accept card payments. We also clarify further that we only allow Visa and American Express in this example. And we're also saying that the billing address is required and that the phone number is required as well. The user will be informed that these things are also required, and they will come to you as part of the Google Pay payload. The final thing we need to do is add the API version and combine it all together, which we do here in the Google Pay client config. Once we have the client config ready, we can finally call isReadyToPay. It's an asynchronous function returning a promise, and once this promise is resolved, you get a true or false, a yes or no answer saying if Google Pay is supported on this platform. If it's supported, then you can proceed to actually create the Google Pay button and add it to your website. And creating the button is quite easy as well. You just need to specify the color, which can be black or white, the type, long or short, and an onClick handler, the function that will be called when this button is pressed. Finally, this function only returns an HTML element. It doesn't actually add it to your page, so you'll need to add it to some sort of container. I'm using a pen child here on some container element to add this button, and this is the end result on the left. Now we just need the onClick handler, where we will call loadPaymentData. Before that, we need to add a few extra arguments. We'll first use object.assign to make a copy of the object that we already created for isReadyToPay, because we probably want to share the same things we use there, such as which card networks we accept. We add information about the transaction itself, which is the total price amount and the currency that we're using. The final thing we need to do is add information about us, the merchant. The merchant name can be anything, but it should probably be your company name. Well, the merchant ID is something that Google Pay provides for you, which is a way for us to ensure that only verified users can use the API. This is generated by the Google Pay console, so it's a very automated process. Finally, we have everything ready, and we can call loadPaymentData with this object. This function is also asynchronous. Once you call it, as you can see here, the payment chooser will appear to the user, and they'll be asked to choose which card they want to use for this transaction. Now, because we only said we accept American Express and Visa in this example, if they have a MasterCard stored, the chooser will, for example, notify them that this card network is not supported on this website. Once the user has made their choice, they click the Continue button here. This will resolve our promise, and it will return us a payment data object. This object will contain all the information we requested, such as the billing address and the phone number, but the most important part is the tokenized data. This is an encrypted object that contains the user's card information, as well as anything else that's relevant for processing the transaction. As a merchant, you don't consume this object yourself. Instead, you send this encrypted payload to your payment gateway or processor for processing. How you do this will depend a lot on their own API. Usually they would provide some sort of REST API where you can send it, but this is something that you need to refer to in their own documentation. In this case, we just assume there is some process payment function where we provide this encrypted token. Now, there are a few best practices that you should follow. One is, you should always call load payment data in response to user input. It's best to call it the first thing in the on-click handler for the Google Pay button. This way, you ensure that something like a pop-up blocker is not triggered, because this function may actually create a pop-up on some browsers which have no native support for payment request. And in this case, the pop-up blocker would trigger if it's not triggered on user input. So make sure you call this from the quick handler and not anywhere else. Also, always load our JavaScript library asynchronously. This is to make sure that your checkout experience remains fast and is not blocked by the loading of this library. And now, the part that everyone except the person presenting is always anticipating, I will now do a live implementation of this and just go through all these steps quickly again. So what I have here is a web page that will refresh when I change something in Visual Studio Code. And the first step is to include the Google Pay JavaScript library. Now, I created several macros to make this easier for me, so I don't have to remember it by heart. But here we just included the script element with the relevant URL. The next thing to do is we need to actually create the onload function that will be called when this script is loaded. And we need to ensure that this function is actually called. We also have a status element here that we'll use to actually print some information. So let me just quickly print something there if the library is loaded. And as you can see here, the library has been successfully loaded, and we can proceed to create the Google Pay client. We'll store it in a global variable for this example. We'll use the test environment, of course. And here we have the Google Pay client instantiated. Now, the next thing to do is write all those parameters that we had on the slide. The first one is the tokenization parameter. Here we'll say that our processor is example, and we'll use 123 as our gateway merchant ID. We also need to say what type of card we support, and so we'll say that we support card payments. We already have the tokenization spec above. And let's say we support both Visa and MasterCard. And we will also request the billing address. Now, the next step is just to create the client config as well, that combines all this together. So the only allowed payment method is card. And we will also provide our merchant information right away. Finally, with all this, we're ready to go, is ready to pay. We we can make this function async so that we can use await and simplify a few things. And we'll move our status print to actually show the result of this. As you can see, the call is quite fast, so we already got the result near instantaneously, and Google Pay is indeed supported on this platform. We'll still add if just in case. And now we can proceed to call create button to actually create the branded Google Pay button here. We'll use the default color and we'll use the long variant of the button. And we'll add this element to our container. And as you can see here, the button is instantiated. The default variant is the black one, and now we have the branded Google Pay button that unfortunately doesn't do anything when clicked, but we'll soon fix that. We need to have a function that's called when the button is clicked, and this function will also be async because we'll be calling load payment data from there. Now, for load payment data, we need to add information about the transaction as well. So to do that, first we'll make a copy of the existing client config that we have. And now we will add the transaction info to this object. And we'll put some arbitrary price. And this is pretty much everything we have, because we already defined all the other parameters above. The only thing we needed was the transaction info. And we're now ready to actually call load payment data. It's also asynchronous, so we'll use await here. And we'll move our status code to actually print the result of this. Finally, we should probably actually set the onClick handle here to be our new function. Wow, something went wrong. So we should probably move all these to be in the global scope, otherwise we won't be able to access it. That's much better. And as you can see here, I'm already offered the card that I have saved in my Google account. I can also add a new card right here from this selector, but in this case I'll just use the one I already have. When I press continue, the promise is resolved, and the payment data is returned, as you can see. So what you can see here is this contains description of the card. It also contains some of the parameters we provided, like the API version, just to verify that everything went through correctly. You cannot see the card number anywhere. As I said, in reality the card number will be encrypted, and it will be one of the fields available here. But because we're using test mode, this is omitted as well. The card number is encrypted using the payment gateway's public key, so that only your payment gateway can actually access this. This means that in case the website is compromised, even if this token is somehow stolen by a man in the middle attack, this would still not be very useful because only your payment gateway can decrypt this token. In addition, because the transaction itself is isolated in a separate window, it's impossible to actually hijack this page either and perform a phishing attack or anything of the sort. This means that this transaction is secure by default, as the information you get on your page is not actually something that can be used to create a fraudulent transaction if any part of this system is compromised. And finally, here are some resources that might be useful for you. Our documentation, of course, is the most important part, where you can see all of these functions explained in more detail, as well as the various parameters that I've covered here. There's also our B2B site on the other link that you can check out. And you can also try our code lab on this bit.ly link, where you can basically do a similar thing that I've just done, but on your own on the Glitch platform. And I hope this made things a bit more clear about what Google Pay is and how it can help your checkout experience. I'm open to any questions, and I'm also once again reminding you that there is a Google Pay stand that you can just come visit right after, where you can ask any additional questions or try out our live demo. Thank you. Well, I assume no questions means everything was clear.
Can you say a few words about the implementation on the mobile platforms, or is it?
Yes. So on the Android platform, we have an API that's practically exactly the same. So pretty much all the parameters that you've seen are true for the Android platform as well, except that you need to include the SDK, which is part of the Google Play services. The UX is also exactly the same, as we tried our best to make sure that it's consistent across platforms.
Do you know if it's open in a browser or as a native?
No. On the Android platform, it will be a native dialog that's spawned inside the app. This is also true on Android if you use Chrome. So to clarify, Google Pay will always try to use a native implementation if it's possible, which it is on Android and in recent versions of Chrome as well. If this is not possible, then a pop-up window is spawned.
Okay, thank you.
One last chance.